Hi, this is Margo. This is Sunday, late afternoon, early evening, August 27th, 2023. I hope everyone is safe and doing as well as possible. And another week has passed and they're just zipping by. And anyway, we're here again for this will be our weekly weather roundup, well, not weather, exactly climate roundup, where we look at the climate around the planet. My main focus is on tracking methane and sea ice, and then I'll share some other things too. And this is kind of a learning channel, because when I started this a little over 5 years ago with exploring the different programs on the internet like Climate Reanalyzer and CAMS and different ones, as I was discovering how to read the data and everything, I started making videos about it, and people liked it, and so I just kind of fell into this, and so I've been doing this for over 5 years now, and we're seeing everything getting worse, and the main words out of all the climate scientists' mouths now are, it's worse than we expected, and it's happening sooner than we expected. And so whatever we have access to, just know that it's worse than what we have access to, and it's probably a lot worse than we know. So anyway, I thought I'd like to change up the format of the show a little bit, and I thought I would start going over viewer comments at the beginning of the show, and because I've been getting quite a few that, you're asking questions and wanting me to answer and discuss and things like that, and it's easier just to talk about it. And I appreciate all of your comments, and I appreciate everyone watching my videos. It's a small group, but you're eclectic, and I appreciate every single one of you here. And I do have this comment set that they're held, and I review them before they get posted. That's to just, peace of mind, and to keep trolls out and things like that. So I'll just go over all of them, and the first one is from Ed Tremblay 6694, and he says, "Thank you for all your time spent on this information. I'm an avid follower of your channel and totally appreciate all that you do. Thanks again." Thank you, Ed. I appreciate you. And Lightning Rod says, "Grateful for the knowledge, Margo." You're welcome. Thank you for being here, Lightning Rod. And then Angel's Place always leaves me a sweet comment. Thank you, Margo. You're welcome, Angel's Place. Thank you for being here. Okay, here's our first one that wants me to talk about stuff, and this is from A. Meyerhofer, and he says, "Hi Margo, great job as every week. Thank you. I'm a novice, but for years have been following your reports each Sunday. I'm wondering if it is typical to have almost always lots of clouds over the Arctic. I'm asking because I wonder what would happen if a period of time with fewer clouds and direct sunshine would occur. Maybe it's just when you come to the part where you zoom in to look at the ice and open water parts, but to me it feels like almost never are there large areas of no clouds for you and anybody else to really observe the surface. Why is that? I've been wondering the same thing, and that's a good question. It's always cloudy in the Arctic, and it's almost always cloudy in the Antarctic. At certain times of year when the sun is at a certain angle, it picks it up with fewer clouds, as the sun is lower on the horizon, I found. But it's very frustrating, I know, and so you kind of have to learn to look through the clouds and the layers of smoke and different things that we're looking through. But this is why we look at all the different models, so that we kind of have an idea of where the ice edges are and the thicknesses and concentration before we even go to NASA Worldview, and that helps us too. And one thing that I'm upset about NASA Worldview about is the no more nighttime Earth at night layer. The Earth at night layer was wonderful, and with that layer, even in the wintertime when it was dark up in the Arctic, we could see everything, and it looked like there were a lot less clouds too. I don't know if it was just because it was cold or what, but we were able to see the sea ice and the state of the ice and everything. And I don't know if they're going to bring anything similar back, but I'll be looking for that. But thanks for being here, and thanks for asking your question. Be sure to, anybody who wants to ask a question, just ask it. What else was I going to say? Oh, and it could be, I did the thing on the Tonga volcano a few weeks ago about how much water vapor has been added to the atmosphere as a result of it. And with the extra water vapor, you're going to get more clouds as well. And the clouds also hold more moisture, as we're seeing, and so that's going to be true for the Arctic as well. So this clouds are just a fact of life, and we're just going to have to deal with it. And so thanks for being here, and thanks for your comment. And then Christine Armington says, thank you, Margo. You're welcome. Thank you, Christine. And then Larry Taylor, he's one of my regulars, says, I used the NASA sea ice concentration layer and looked at Antarctic ice. I went back to last winter, and it looked like today's level is about like October 20th, 2022. So we're almost 2 months ahead of schedule for the melt. I'd like you to give your opinion. Okay, we'll look at that tonight, Larry. It could be we're ahead. I know that the refreeze in the Antarctic has been terrible this year. It's at record lows, and it's thin in a lot of areas, and we've got holes in areas that we didn't have this time last year. So, the Antarctic ice is in trouble too. So we'll look at that. Here's our next one. This is from Marnie Madsen. Thanks as always. A couple thoughts. For Brennan School, at this point, what's the difference between failure to refreeze and melting? It's for thin ice, so either tech is not ready or accurate, or they are downplaying. It seems tracking loss of albedo may be more reliable and is really the dire effect. Yeah, how would we track loss of albedo? I'm not sure how to track that. And then I appreciate you trying to make the mouse pointer more visible. For me, the color overlying the temp charts is really distracting. Like, I want to see what you're pointing at, but the pink or any color is distorting the map color, and then you're moving on. Just my vote, but prefer plain arrow. Okay, now we know, and I've switched it back to the plain arrow, so I appreciate that feedback. And then also wondered if you'd ever thought about tracking O2 levels. I don't know if you're referring to oxygen. Oxygen is just O. O2, some people consider that dioxide, so I don't know what you're talking about there. They are dropping as the oceans heat, plankton dying. Seems critical. It seems like you're meaning oxygen. Oxygen is just O. Last thought. Oh, well, tracking that, I don't know. I'll think about it. Last thought, which you've talked about, but clearly the methane being obscured, those huge areas of missing data are skewing all the averages and likely hiding the extremes. Thanks so much again. And you're talking, okay, where the missing data, you're talking about the gray area on the NOAA pictures, NOAA methane GIFs, and those gray areas are there no matter what. I paid attention when it was all gray, like in the northern hemisphere, and then, I disregarded those readings. But as long as, the gray is about the same, what we're looking at is averages anyway. So, and, we can still track it. But thanks for your comment there, and thanks for watching. And Larry says, merci beaucoup, Margo. You're welcome, Larry. And then CG000GC says, it's talking about the Brennan thin ice thickness model. Being inaccurate does not mean that the situation is better. I agree. In fact, the thickness can be even lower than they measure it through satellite imaging. There is also the question why these researchers are leaving the map there if they know it is inaccurate. In fact, can they even be considered as researchers in this case? Well, I happen to agree with you. And so I just, now that we know that that model is not meant for the melting season, and frankly, I'm not going to use it because it's confusing to me. But now we know, and so this is why it's important that, we keep learning and we keep exploring, and, when there's something new that comes out with a model or something, I'll let you know. And just like on CAMS, whenever, they change their website or change a color chart or something, I'll let you know so that we know that it's not what we had been seeing. So thanks for the comments, guys, and thanks for being here. So now we'll move on, and we're starting with Climate Reanalyzer, and we're looking at 2-meter maximum temperatures around the planet today. And we're still seeing a lot of greens in the Arctic. We've got some aquas, though, over the basin, and that's 0 C or freezing once it reaches the light aqua here, and it goes into darker aqua as it gets a little colder, and this is air temperature. We're still seeing reds in North Canada, all the way through Canada, and it's coming down in the southwest, California, Arizona, Mexico, Texas, and so on. This along the Gulf Coast, we've got whites as well, and so they're dealing probably with wet bulb issues too, with it being humid and hot, and the whites are 40 degrees C or higher, or about 104 degrees Fahrenheit or higher. And we go on down, and South America, Brazil, you've got a lot of whites. Africa, and seeing the Congo area, you've got whites too. In Central Africa, getting more whites all across the north. Saudi Arabia, Middle East, and so on. We've also seeing whites up here, just above the Mediterranean. I'm not sure of all those little countries. This is Italy here. I think that I think this is Greece down here, so that's above that. And then over to India. Here's 2-meter temperature anomaly, and we've got browns coming in over the Arctic, reddish brown in Siberia. This is on the coast of the Laptev Sea. Browns up here in North Canada, up into Alaska, and then blues next to it, then browns. Look at this, and blues right next to it. And we did get the aftermath of Hurricane Hillary last week, and there was something toxic in the water. I definitely reacted while, for a few days while it was here, but we didn't get a lot of rain, and no flooding. It was just kind of the aftermath, but anyway, here we've got browns look at this dark brown over western Russia and coming down Africa. You've got browns. We've got browns over most of Russia and coming down. This is Mongolia here, coming down into China. Australia, you've got browns. The Antarctic is browns, mainly browns and blues, and then some purples. Here's our overview. Worldwide, we're up 0.84 C, higher than normal. The northern hemisphere is up 1.09 C. The Arctic is up 1.88 C. The Antarctic is up 1.71 C. Southern hemisphere is up 0.59 C. And the tropics are up 1.03 C. So this is really heating up. All these 6 areas are higher than normal, and 4 of them are above 1 C, higher than normal. That's the tropics, northern hemisphere, Arctic and Antarctic. So I think that means we're in runaway warming. We're runaway heating, I think, is what that means. Here's precipitation and clouds, and we've got rain here around Greenland on both sides, and snow on this east side. Rain up in the Baffin Bay. Rain here in the Kara Sea. Then we've got snow across the Arctic Basin. Rain over most of Alaska. Snow and rain-snow mix over the Beaufort Sea. And some rain and rain-snow mix here over the Beaufort Sea as well. There's also down here, coming up from the Gulf of Mexico, is a new hurricane that's going to hit Florida. There's also one out in the Atlantic heading, going to go up the east coast of the U.S. And we can look at that on Zoom Earth in a minute. So this is the season. Here's the flat view. And here's the what used to be the jet stream, and it's just loops and pieces now, parallel looping here. And see these circles, low pressure. Here's the flat view, and the southern hemisphere is bad. I mean, it's looking worse. There's just no rhyme or reason. And we'll look at sea ice separately, and then sea surface temperature anomaly. This is for yesterday, the 26th. And here in the Arctic, here in the Kara Sea, we've got pinks moving into white. And remember, they expanded their chart on the right here up to 9C higher than normal and 9C lower than normal. So pink is about 7 to 8 C, higher than normal, and then into the white it's 8 to 9 C. Then browns in this Barents Sea and the North Atlantic, and where it's been ice-free for a while, you can see the water's heated up, and this Lactav Sea along the coastline is in reds and pinks, and then this East Siberian Sea is in the browns, and Beaufort Sea, we've got browns out here, and then along the coastline of Alaska and Canada we've got reds. These tributaries in this Northwest Passage Sea, these are brown. These are open. That's all melted. This is where you see it's brown. There's no ice at all there. So they're $38,000 a seat excursion, I'm sure, took place with no problem. And Baffin Bay is mainly in the browns. Got a little blue. This is from the ice running off, the melt from the ice sheet. There was extreme melting on Greenland this week. There was rain and snow. It got up to, I think it was 45% melt one day this week. And then here in the North Atlantic, we've got, here's our Evil Eye blob from Newfoundland all the way up to Greenland. It's in the reds and browns all around. Hudson Bay is in the browns, and we're seeing darker shades of brown sea in the Atlantic here. Now here's the Gulf. Now I know it's warm. We've seen it warmer though, but I mean that's still warm, and so any hurricanes coming up, it's gonna get that warm water and fuel it. So, and the Atlantic is all in the browns too. And then now we've got browns on the coast of California and just off the coast of North America up here, and then the blob, and we've got several blobs we'll look at. Here's the flat view, and here in the Atlantic it's almost all in some shade of brown. Here's the Mediterranean. We've got red and brown on the west side in this bottleneck where it comes goes into the Atlantic there. And then the Black Sea is brown, Caspian Sea, Persian Gulf, Red Sea, those are all brown. Indian Ocean is mainly brown. And we've got reds and pinks off the coast of Japan, and I don't know if y'all are aware, but Japan just a couple of days ago started dumping nuclear radioactive water from the melted down rods into the Pacific Ocean, and it was already going into the ocean anyway without them dumping extra, because it was never fixed, and so now we've just got more added to it. So I expect to see this area east of Japan just heating up, and that will probably become a permanent blob area, and it could be spreading out. And then here's our blob in the North Pacific there, and then down here next to South America and right along the equator, we've got a really thick blobby area of red and brown all the way across, and then brown in the southern hemisphere too. Just a little bit of blues, which are colder than normal, but not much. So El Nino is definitely here, and with that, I don't know if when we'll reach minimum extent in the Arctic this year. Will it keep on melting into October? I mean, really, we're no man's land. Anything can happen. Anything. Okay, now we'll move on to methane. And we're looking at the NOAA methane data for yesterday, the 26th. Met-Op-B satellite in the morning, starting with the 1,000 millibar level. The mean or average was 1,843 parts per billion. And the highest readings are these pink areas over Russia, and the gray, that's the QC fail. That's where they don't get a reading. They don't have a reading, but it's kind of consistent amounts of that, and so if it's consistent with the grays, we'll just keep on doing what we're doing. I mean, this is what we've got, and we'll just keep on doing what we're doing. In the afternoon, the mean was 1846. On the Met-Op-C in the morning, the mean was 1844. Pink's in the same places over Russia. And this pink is a range between 2,000 parts per billion and whatever the highest number is here. And here it's 2,026. So this is surface level that they're measuring. And in the afternoon, the mean was 1845. At the 487 millibar level on the Met-Op-C satellite, you can see the difference. Here we have a lot more data available at this level. It's almost all in the pinks, a little bit of red around the equatorial region. So Met-Op-B in the morning, the mean was 1925. And you see the high reading was 2493. That's a spike. It's a spike for sure. In the afternoon, the mean was 1930. On the Met-Op-C in the morning, the mean was 1894. And see, it's over a lot of the northern hemisphere, and it's coming further south. And we also have it next to the coasts of Antarctic here, of the Antarctic. Look at this. This is the afternoon, and the mean was 1896. And see, it's not only next to the coast, it's over the interior. So So we've got some higher readings there. So we'll go to our charts now. Starting with the METOPS-C satellite only for the 487 millibar level, and this is about halfway up in the atmosphere, and this is as close as we can get to the 500 HPA level on CAMS. So the 26th averaged out to be 1895.0, and that gave us an increase this week of 4.0. So back up right at that line there. And we're still in the warming season for methane. So let's see what happened here this week. Here we were in our show last week. The 19th ended at 1891.0. The 20th went up 1.5. The 21st it went up 2.5. 22nd no change. 23rd down 0.5. 24th up 0.5. 25th up 1.0, and 26th down 1.0. So by the 25th we were 5.0 higher this week, but then it went back down for Saturday. There's that. And then for the all four readings on 487 millibar, the 26th averaged out to be 1911.25, and that was an increase of 4.25 this week. So again, so with all the readings together, we went up to. And then on the 1000 millibar level, the 26th average was 1844.5 with an increase of only 1.0. So we can see that at surface level the change is usually less than higher up in the atmosphere. So there's that. And now we'll look at the CAMS methane data. This is Copernicus Atmosphere Monitoring Services out of the EU, methane forecasts. And our base time and valid time are both for Saturday, August 26th. And we're starting on the Arctic area and surface level here. So the data is for Saturday, and the forecast period is Sunday, Monday, Tuesday, Wednesday. So here in the Scandinavian area over to West Russia, this is kind of a constant blobby area, especially in the summertime with the warmer temperatures. And you can see the high reading streaming over the coastline over in the Norway Sea here. Look at that. Russia's filling up as well. And Komsomolets, well, let's see. So here it's starting over. It's been just billowing and hemorrhaging all week. And there's another little blip here where it likes to come up. And it goes down for a little bit during the forecast period, so I don't think that's a permanent thing for sure. And then the high readings spreading out all across Russia here as, the temperatures, it's hot. We're getting late in the summer, and the earth has been heating up. The ground is heating up. The permafrost is thawing. They've been having some fires, not like Canada and Maui. That was terrible, and we need to pray for them. But it's just we're in trouble. I mean, the whole planet. I mean, we're in trouble big time. Here's Alaska, that's come back to life. With the rain, that'll heat back up. Canada, look at that. That's where the tar sands are. So lots of fires up there too. Here's North Dakota. That's a constant. Here in the U.S., see, pretty blobby. West Texas, Southern Texas, then this upper and middle part coming all the way across. And our problem spot in the North Atlantic, I thought I saw that pop up. Yeah, there it is. Just hinting at popping up. There it is. That's in the forecast period. And also a spot on Iceland popping up. So there's that. And then we'll go to the North Pole view. And really see it streaming off of Norway there. Here's the UK and Ireland, they're filled up. Germany, you've got quite a bit. Here's the Persian Gulf, India, China, and then this goes north up into Russia on this east side. Here's Korea. And then Mexico, especially like the southern part, down into Central America. Of course, that's like really humid. They get a lot of rain. And it's hot. As you get closer to the equator, you're going to get more methane too. Same thing with South America down here. And then these waves, see these waves of green, yellow, green. That's high methane. Here in India, see it's spilling over the coastline in this Bengal Bay. And in the forecast period. You see here. So that's a surge. Same thing with China, that's surging. And then global view. And here in the southern hemisphere, our main background color is this light blue, which is 1860 parts per billion. We still have a little trace of the darker blue coming in. That's 1840. It's still hanging on, but you know, it just kind of comes and goes depending on the day. And then we've got the next higher reading with the greens. That would be 1880 around Australia and Indonesia, this area here. Okay, and now we'll look at 500 HPA. So this is about equivalent to the 487 level. And here, look at the heavy parts migrating south. And red further south, orange further south. See, it redistributes as the summer moves on. We've got heavy here over the southern U.S. That's kind of unusual to see that. And then total column. And look at this. Look at this wide band. Now, I had been calling this the Loch Ness Monster, but the head broke off. So his head is out here in the Pacific. That's the head, and then there's just a wide band. I don't know what this is. Just a wide band from China all the way across, and you know, it's looking worse every day. It's coming further west over Africa, over more of Africa. So there's that. And now, just a couple more things from CAMS. This is sulfur dioxide today. This is volcanic action down here in Peru. Also, this is from Popocatépetl in Mexico. I have no idea what this is from. It showed up like this today. It was nothing yesterday. Brand new, huge area of sulfur dioxide in this C shape, or backward C shape, across Alaska and Canada. I don't know. I have no clue what that's from. And here it is at 500 HPA. And so compared to the volcanoes, this is humongous. This is a lot more than what's coming up from the volcanoes. So whatever it is, I sure would like to know what that's from. I don't know if it's sulfur dioxide, the sulfates falling out of the atmosphere as we cut down on our greenhouse gas emissions, or what. But that's, I don't know. Or, could it be a weapon that went up and got spread out in the atmosphere? I don't know. It's anybody's guess. Here's the ozone hole over the Antarctic today, and we can see that it's growing, and the little holes are merging into a larger hole, and it's down 3 levels in the danger zone, and anything inside this black circle, that's considered in the danger zone, and the bluish purple is 200 to 220 Dobson units. The regular blue is 175 to 200, and then this kind of navy blue is 150 to 175 Dobson units. And it's covering this whole west side of the Antarctic, and then we've got more holes, one on the east side and one on this southeast edge, and then blues, aquas and blues, and then it's heavy. It just gathers heavy around there during their winter time. Here's the ozone in the Arctic, and we can see it's thinning down, and we've got aqua here. This is, I would consider this a hole. All of this green and aqua over the North Atlantic. This is Svalbard, and this aqua goes all the way up to the Kara Sea, and then the greens, and things that will eat away at ozone. Methane is one. Radiation is one. Also, sulfur dioxide will eat away at ozone, and wildfire smoke. So it's a combo plate here. I'm thinking it's mainly from the high methane there. And then we've got green over Canada. This is from the fires and the whole western US and across. See, and see that the rest of the US is in yellow green. So this solid yellow, that's 300 Dobson units. That's considered to be an average number or a good number. So anything starting with the yellow green is thinner than that. Here's the global view of the ozone. That looks very bad. See the green all around these equatorial regions. And here's the smoke today as registered on CAMS. We'll look at North America in more detail in a minute. It's mainly up in Canada today. Here we've got smoke. These are from fires in Brazil, mainly South America, and then here in Africa, mainly the Congo. Here's North America, and we do have wildfires on the west side of the U.S. They started late this year, and we don't have that many, but they're in Oregon, Northern California, Oregon, Washington, and then of course it's still burning in Canada. The forests are just, they're all burning down. It is so sad. And then here the smoke is drifting down over parts of the U.S. And look, we've got smoke in East Texas, looks like, or in Louisiana, if there are fires there. And that's all of those. Alright, I'm going to take a break, and then I'll come back and record the sea ice part of the show. Stay tuned, I'll be back. Okay, I'm back. Before we go into sea ice, I just wanted to quickly go over these hurricanes here on Zoom Earth. Now here's one going out into the Pacific, but I'm not sure where that's going. Just out in the ocean, I think it looks like. Anyway, here's the one coming up towards Florida. It's coming up. It just came on the west end of Cuba and coming up through the Gulf. And this is the path. Here it is right now. And this is okay, that's not a dahlia. I thought that was a dahlia. Yeah, a dahlia. Okay. Okay, yeah. Okay, this is a dahlia. Look at this little circle it did. How weird. Anyway, here it is right now. It's a tropical storm right now. 45 miles an hour as of 5 p.m. on the 27th. And then by 11 p.m. on Monday night, it's gonna be up here, and it turns into a Category 1 hurricane at wind speeds of 75 miles an hour. By Tuesday morning, still coming up, still it's a Category 1 hurricane there, 85 miles an hour, and then it looks like it's so it's not going to make landfall at Tampa, but Tampa is going to get a lot of rain. But the eye is right up here. This is the 29th, 11 p.m. Hurricane Category 2, 100 miles an hour before it makes landfall. And then See, all this coastline has got a hurricane watch, so you'll need to get your supplies now and get hunkered down and be ready. Be ready. And then it's gonna come on land and cut across Florida, west of Gainesville, and go up into Georgia, and then out. Then it's gonna head out into the Atlantic. But you can see the path of the storm is wide, especially when it gets back out over the Atlantic, it looks like. But so there's that, and then here's this one brewing. It's coming. It started just north of Venezuela and headed west, and then it came north through Dominican Republic, and then did a little zigzag here, and here's the hurricane. It's a Category 2 hurricane right now. This is Hurricane Franklin, and it looks like it's gonna get up to Category 4 on the 29th. 130 miles an hour wind. But the good news is it's steering away from the east coast of the U.S. So that I was mistaken. It's not going to go next to the coast. We shouldn't get any rain from that. If there are any little islands out here, that's what you got to worry about. So Franklin is right now a Category 2 hurricane. So there's our hurricane report. Alright, now let's move on to sea ice. We're going to start with our slideshow here from Climate Reanalyzer. This is sea ice concentration and snow cover. So we'll zoom in here. This is for today, Climate Reanalyzer, and you can see this Baffin Bay open. All these tributaries are open, just a little bit here, frozen next to Ellesmere Island, and then this Beaufort Sea is melting in further. Look at this East Siberian Sea. The little bridge collapsed this week. There's no bridge of ice going across. There are just spots of ice there. And look at this, is such a weird thing here. So here's some ice just west of Severnaya Zemlya, and otherwise the Laptev Sea is open. And here this hole is opening up diagonally from the Laptev across towards Svalbard, and this top part is collapsing all around. And when we look at the Navy model, you're going to see this ice, what's left of the thicker sea ice, just above Ellesmere Island in Greenland. That's disintegrating too. That's breaking up. We still have some ice on this east edge around Franz Josef Land, but it's melted in around Svalbard, and it's pretty much open in the Kara Sea and so on. So all of these coastlines of Canada, Alaska, and Russia, they're all open now. So let's click through and see what happened this week. Here we were last Sunday. So here's Monday, Tuesday, Wednesday. So that was a big retreat up here on Wednesday. Thursday, and you can see a big retreat here in the Beaufort Sea on Thursday. Friday, Saturday, and here we are today. And they're getting some snow. You see the white on land. That's snow. And we also saw earlier that there's some snow on the ice too. Now we'll go through these other models. This is from the U.S. Navy. This is Arctic sea ice thickness for today. And our color chart on the right, you can see it's mainly purple, blue, and aqua, our main colors. The bright aqua is about 2 to 2.5 meters thick. There's very little of that. Here, see in these tributaries, what ice there is just little fringe ice here. And look right here, see the dark, that's where this thicker ice is breaking up. And see it's diminishing on this west side. It's kind of sliding, and then it gets smashed into these tributaries and exits. And another exit point is the Nares Strait, and also the Fram Strait. It does flow out to the east of Greenland too. And we're seeing a hole right next to the Greenland coastline where the ice is pulled away with the ice drift, and a big hole on the east side here. Very little bright aqua, just a little line along Greenland, and a little bit here just north of Ellesmere. And these other aquas are darker, and they're thinning and coming apart. And the majority of the Arctic is in, if it's not open water, it's in lavender, light lavender, into the whitish. Wherever you see white, that's open water. And it means that the ice has come apart. It's just in pieces, it's just in ice cubes, or it might be even just really thin and wispy or mushy, or just not very good ice. And we're still seeing some dark blue here at the North Pole, which is about 1 to 1.25 meters thick. And see the lavender up here in quadrant 1. Here it is in quadrant 4. Quadrant 2, we've got a lot of open water here, and then from Franz Josef Land down towards the North Pole in this quadrant, it's purple and blue. So like 1 to 1.25 meters thick. And then here in quadrants 3 and 4 is where the thicker sea ice is left. just above Greenland and Ellesmere. And the little green line there, that's about 3 meters thick, and the bright red is about 4 meters thick, and the dark red, if you can find any, is about 5 meters thick. Here's the 30-day animation. It was updated to today. So the data goes back 3 weeks, and the forecast goes out till next Sunday. So let's see what they're showing. Now next Sunday will be September 3rd. Yeah. Friday is the 1st. Hard to believe. And next weekend is Labor Day weekend. So usually the melting slows way down by the end of August, moving into September. I mean, it's still melting, but it starts slowing way down, and then it usually reaches minimum around September 19th or 20th. But like I said, given all of our unknown factors and unusual factors this year, it may continue to melt for a while, maybe into October. And the ice, even if we start getting some extent coming back, the underneath part will melt because the ocean water that's come in is warm. And another thing we'll have once the refreeze starts is heat will be trapped underneath the ice, and so that could cause the methane clathrates to heat up. I mean, I don't know why it'd be hotter than with the way it is now, but anyway, that's what they say. So it's still, so it's diminishing, this thicker ice. Here, we'll stop it. Okay, here we are at the end of the model, so next Sunday, and you can see we've got a little slump in here, and the ice seems to be breaking up here around the Lincoln Sea, and usually like the ice on the right side flows towards the Fram Strait, and the ice on the left side flows down towards the Beaufort Sea. So let's go back. Here we are today, and so we'll just click through slowly and see what we can see. Okay, so it pulled away a little bit from the Greenland coast, and then that's the ice drift, and then it went back towards the Greenland coast, and we've got a little indention here with thinner ice coming in just above where, here's the Lincoln Sea, so it's above that. So It looks like everything's just kind of holding. Probably a little more melt, but I don't know. Will we have a blue ocean event? I don't know. And at this point, I don't think it really matters that much because we're having the effects of it already. Here's the Beaufort sea ice thickness, and they changed their model up a little bit, and see, it used to look like this. Used to be a big picture. Now it's a smaller picture, and so here's and it says GOFS. That's Global Ocean Forecast Systems. So that's I don't know. That's different from the GLB, but I don't know. I mean, you never know what they're going to do. The chart is the same over here, and so see all the open water here in the Beaufort Sea, and see the very thin, that's just practically not there when we look at NASA Worldview. And this is weird. See, that's where they changed the model, where it moved down, I guess. So the 30-day animation, it only, okay, it's 30 days. They changed this. The last day is the 26th, it looks like. So here we are on the last day of the model. So these are added hours, like 118. That's what it looks like. Let's see. Is that hours? Yeah. Maybe so. So this is new, the way they've set this up. So, let's go back. Uh-oh. What am I doing? I just want to see where it starts, where the model starts. So it starts on August the 5th. So this isn't really 30 days. So even this is the GOFS model. Alright. Let's get this going. So it looks like it forecasts out a little bit past the 26th, 180 hours. See? I guess that's what that means. Hold on. Okay, so 180 hours is 7.5 days. So if we take 180 divided by 24, that's 7.5 days. So it does go out. So it's just marked differently. So it does forecast out to next Sunday, it looks like. Because this is from the 26th. It starts at the 26th, which was yesterday. So there you go. So it's still thinning down. So it's always something new, isn't it? This is why I say this is like our classroom, going over all these things every week. So this is where they're showing it to be next Sunday. Okay, here's the Antarctic sea ice. This is for today. Sea ice thickness. You can see a little thickening here in the Ross Sea and further up here. Here in the Weddell Sea, this is our thicker sea ice. The majority of it has been like sliding down along this western peninsula, and then I see it's pulled away from the tippy point and moved over to the east a little bit. But it looks like a little refreeze is going on there. And we've got more aquas coming in around some of these coastlines. But it's really thin right up here on this northeast edge. There's a hole here, and it's thin right here. This is at Amory Ice Shelf, and also here at the Ross Ice Shelf. And here's the 30-day animation, and the forecast goes out to next Sunday. So we're still looking for extent regrowth. So it's winter time down here, but the sun is coming up. But the regrowth happens until around the same time we hit the minimum in the Arctic. So this the maximum down here should be sometime in September. And we see it's thickening here in the Weddell Sea, right there. Okay, now this is the Ross model for sea ice thickness, and we can see that they changed this chart to match the other chart, the first one. See, it matches colors here. And just last week I had showed that it was a different chart, but now they changed it, and so now we're not seeing aqua all the way across in this Ross Sea. I think someone from all these different websites must be watching my shows, because after I point something out, then, like a week or two later, it's changed. After I point something out that is a little off. So we've got here's the Ross Ice Shelf down here. Here's the southeast edge of Antarctica. Then we've got aquas down here around this coastline, but this is mainly purples and blues. So 1 to 1.25 meters thick. And here's, see, isn't that funny where they changed it? You can see there's the old, it's a 30-day animation. Here's the old color chart. See, went up to 3 meters. Now it goes up to 5 meters. Isn't that funny where they changed the models? So there you go. So there's that. Okay, here's National Snow and Ice Data Center. This is Arctic sea ice concentration. This is for yesterday. And this Baffin Bay is open. Hudson Bay is open. Got little fringe ice on this east coast. And see, all these tributaries are pretty much open. Here's the main passageway for the Northwest Passage. So that is wide open, and then it's just a little bit of ice where it opens out into the Arctic. And wherever you see blue, that's melting. The darker the blue, the more the melt. And the brown is the median, so we're well under that. And so here we're seeing melting around the Greenland coast here, and that this has to do with that thicker ice breaking up. The same here at Ellesmere, and see the line coming down from the North Pole. So that thicker ice, it's like it's dividing here at the Lincoln Sea. Here's our diagonal hole, and we can see there's more melting here around the North Pole today too. Very little solid white, meaning fully concentrated. Here's the extent chart on our melting. The blue line is this year, the dotted line is 2012, and this gray line is the median. And we're still headed down, running kind of parallel with 2012. Here's the Antarctic, and see the darker blue here on this northeast edge. That's where the hole is. And here's our refreeze, and here's this year, and we can see it's angling up, so refreezing a little bit more on the extent now. We're still at record lows. Here's last year. We're well below this time last year, and here's the median. Okay, now for Greenland. Yesterday, here's the melt around this southwestern edge, eastern edge, and a little bit around the north. Now earlier in the week, this bottom area this whole thing was melting and a bunch on top. And here are the cumulative melt days for this year, and the white area is diminishing, meaning 0 melt days. And so it goes from blue through the rainbow back up to dark red and black. So we've got like moving into the purplish region here on the west side. 70 to 80 days of melt. That's a lot of melting, considering it's only really from April until September is the main melt. And here's our extent chart. Look at this. So we had an active melt week, and right now it's right down here at about 5 or 6% melt. The median is getting close to the bottom, and it flatlines in September and October for the median. But look, it spiked up to 45% on Wednesday. Well, not Wednesday, it would have been the Tuesday data that we looked at on Wednesday. And wasn't just that day that was high, it was high some other days too. It didn't just go straight back down or straight up. Okay, that's all of those. Now we'll move on to NASA Worldview. Here's the Arctic. You can see smoke here from Canada. See the smoke there. So here's Greenland. And yes, lots of clouds, always clouds. It's just a fact of life up here. We'll look at sea ice concentration first. Uh-oh, I didn't mean to do that. What'd I do? That's ice surface temperature. I didn't want that. I wanted blue marble layer. Okay, here, without the clouds, we can see our melting. And wherever you see green, that's holes. That's open water, all the way down to open water in the ice. And so we've got this top part collapsing, and it's still collapsing here in the Beaufort Sea. And we're getting here's this line dividing, coming down from the North Pole. So let's go to last Sunday. We'll see what happened this week. Here we were last Sunday. Okay, here's Monday, Tuesday. Here it comes. Wednesday, that was a big retreat day. Thursday, and see the melting starting just south of the North Pole here. Here's Friday, Saturday, and here we are today on Sunday. So this interior ice is definitely going through stuff. Alright. Now, let's move in and look at our satellite view. And now we do have quite a bit of area with no clouds here, which is highly unusual. Here's the hole on this northeast edge of Greenland, and where it's come away from the coastline. Here's the Lincoln Sea, and here's the ice moving down through the nearest strait. See, that's moving down. And exits down here in the Baffin Bay. So that's melting pretty good as it's going along too. And then on Greenland we've got ice melt. See the blue? That means it's melting. And here's some more melt ponds. See that? Or a lake. I mean, some of these are huge. That's our scale over here, like this length, that's 5 kilometers. So this melt lake is at least that, maybe a little bigger. Here's more melt ponds. Okay, let's see. So Greenland. Let's see what's going on down here. So we saw a storm down here on this west side and also one on this east side. So with those storms and the moist air, the melting from today, which they'll post tomorrow, will probably be pretty high. Let's go to the east here. Here's Svalbard. That's open. Here's this east edge of the ice. You can see, that's really come apart. And here's some more edge. Here's Franz Josef Land. Let's see, that's just wispy ice. It's not well formed. It's very thin. And here's our diagonal hole opening. See, and just look through the clouds and see, there's lots of open water. Everywhere there's open water, it's absorbing radiation and heat rather than reflecting it. So this is come apart, hugely come apart. See, Look at this. Hugely. And it's all the way up. Here's Severnaya Zemlya, and we've got clouds here. Let's see. See, when we have a lot of clouds, that's why I'll go back a few days just to see what we can see. Okay, so this North Kara Sea is opened up. There's a little bit of ice right here, but this ice further up is not there anymore. Today, let's go back to yesterday and see. Here's the hole. Man, look at that. And that's inside the 80-degree north latitude line right there. So this is really collapsing. See here, the whole thing up here. Look how that's come apart. See, and I mean, the best we can do is see patches where there's no clouds, and then kind of extrapolate out in your mind. Okay, if it looked like that right next to the cloud, then it's going to look like that under that cloud. Okay, where am I? Okay, right up here is the Laptev Sea. Look at all these clouds. Can't see a thing. Here, the 24th is the best. We've still got a lot of clouds. Look at these. That's weird clouds. This is open though. And here's the ice edge. There's Taimyr Peninsula. See. And here's the East Siberia Sea. See, open along the coast there. And the ice that's here is practically nothing. See, there's the ice. Practically nothing there. There's Wrangell Island. These are weird clouds. Here's the Bering Strait. This is all open. This is the Chukchi Sea. Here's the Beaufort Sea. This is open. There's Barrow. Here's the ice edge. Look at this. See how wispy that is? But they're counting all of this for extent. So I think it's a little misleading, or a lot misleading, thinking, oh, we've got the extent and it's so good. No. It's, they're estimating anyway. See, look at this. Big hole there. Okay, so here's most of the Beaufort Sea is open. Is what we're seeing. Let's go back. I think the clouds are worse this year. I'm thinking it's water vapor. Extra water vapor. Yeah, see the ice? That was the 23rd. It's worse than that now. So, this is well inside this 80-degree north latitude, and lots of big holes. And here you can see it's melted way in on this west side at 80 degrees. Okay, here's Ellesmere. And you can see it's come away from the coastline. This is that thickest ice. And see the, here you go. There's the ice. That's some of the thickest right there. So that's, let's see. So here's the main, is that the main? Yeah, the main drag for Northwest Territories. I mean Northwest Passage. I'm getting tired. Okay, so it's through here. See, all that's open. There's no ice. See, nothing, no ice to speak of. You're seeing clouds here. Look how this has melted this week. It's unbelievable. And then when they come out on the other end, they've just got this little bit of ice. So there's that. Oh, let's look at our algae bloom here in the Barents Sea. See if we can see it. Oh, look at all these clouds. Can't even see our algae bloom. You can see it. It's gotten bigger. It's come up to the coastline. It looks like. Look at that. Yeah, and look how far out it's gone. All the way to Novaya Zemlya. It's grown. It has gotten bigger. So you can see it through the clouds here. See the green? That's the algae. It's a humongous area. That stuff is toxic. Okay, now let's go to the Antarctic. Here we are today, and we can see the black area is getting smaller, and this Western Peninsula is almost all in the light now, here's the Weddell Sea. This, the north side is in the light, east side is in the light, quite a bit, well, a little bit of the southern end is in the light, and we're waiting with bated breath to see Pine Island Glacier and Thwaites Glacier. Really waiting with bated breath to see those areas. And let's see, it looks like this is right here is the Thwaites Glacier, and what we can see, and this is the tongue, and then that looks like a cloud there. And looks like open water interspersed here. So there's the sea ice there. Let's go around. Here's the Western Peninsula. So here's the wispy ice that refroze. And the thicker ice, remember, it pulled away from this tipping point. So it's over here, the thicker ice. But, you know, it's got a bunch of holes, see? Now, the Antarctic ice does not get very thick because it has to refreeze every winter. Most of it melts in their summertime, and the ice is on the outside of the continent rather than inside in a big ocean, and so it doesn't get real thick. And this is part of the Brunt ice shelf here, and you can see it's pulled away from the coast, or it didn't melt, didn't freeze there. Some of these areas up by the coast, it just didn't freeze, or if it did, it's pretty thin. I'm thinking because it's just warmer there from the, I don't know why, but it just seems to be warmer there. Here's the Amory ice shelf. Here's the sea ice. And then coming around this east side, see the sea ice there. See, it's really opened up a lot. Right down here is the Totten Glacier, and we can see this is just thin, wispy ice. It looks like this was open for a lot of the season, and is just now like getting this thin, wispy ice. And hard to see much. The sun is at a real low angle, and so it's there are these weird shadows and the colors, the blues and blue greens. It's from the sun being so low and the model. So look at all this open water here. So that didn't refreeze there. It doesn't look like. coming around. And here's the Ross Sea. And so the ice comes out to here. And so Larry wanted me to look at sea ice concentration, and he said what October and I think it was the 20th. So oopsies. And yeah, we'll do a comparison. I like doing these. So start comparison. So that was, so the one on the left is 2022, and the one on the right, I want to make that this year. And we can do a comparison. And let's turn on blue marble. There we go. So he wanted me to compare the ice where we are right now with October. It looks a lot less, doesn't it? Especially this Ross Sea is a lot less on the extent. Let's see, here's last year, October. Oh wait, yeah. So the one on the left is October 20th, 2022, and the one on the right is today. Oh, I want to turn on for this one. Turn on blue marble. Oh, it is on. That's weird. Why it's black last year and it's white this year. That's weird. You never know. Here's this hole up on the northeast edge. So we've got a little more ice out here on this west side than last October, but it definitely looks less. And that was I'm just thinking. So, I mean, how much more is it going to refreeze? I don't think very much more. Anyway, there's that. Thanks for having us look at that, Larry. So, now we'll take a peek at some earthquakes. We've got 210 worldwide right now for all magnitudes. Here's a 5.7 Columbia. That's on land. Now I wanted to show this Wanda Fuca plate. We've got activity up here. See, here's one on the plate, 2.5. Here's another one on the plate, 2.4. Here's one on the coast, right next to the plate, 2.0. So, another thing of interest is we've got a cluster of earthquakes. This is on the flank of Mount Rainier, which is a dormant volcano, and any of these volcanoes can come back to life at any time. We've got 8 here today, and 2.9 was the largest. This is on the southwest flank of Mount Rainier. What else? Yellowstone is quiet. We also, here outside of Reno, this is in Spanish Springs. Here's Pyramid Lake. So there are 12. We've got a cluster here, 12, and they're small. The largest looks like is a 1.3, but it's still movement, and to see a cluster like that, you always kind of wonder. And then just, more of the usual movement. Let's see. Southern California, 36. That's kind of an average number. Look at, we got a lot of movement on this San Andreas fault line. See all of these? There's 12 there, all along that line. And then more here in this Ojai area and around it. See, the movement's kind of spreading out. But 9 in this picture, and Ojai is right there. 2.1 is the largest. Oh, look up here. We occasionally see them up here near Lake Erie. 3.6 near Madison, Ohio. And let's see. Let's look at all magnitudes for this last week. 7 days, all magnitudes. 2,274 this week. That's what we're seeing. That's a lot of earthquakes, and you can see all the different movement areas. See this, there's plate movement here in the Atlantic. Here's 5.5, and here's South Sandwich Islands, quite a few down here. Sometimes this really rocks. That's a 5.2, 5.3. Also, there was a 6.2. Sorry, I hit the mic. 6.2 at El Hoyo, Argentina. That was on the 23rd. That was Wednesday. 568 kilometers deep. Very, very, very deep. The deeper they are, the less it'll shake on top. So that's very deep for an on-land earthquake. Look at all of this around South Pacific. Look here, 5.1, Macquarie Islands. See, we had plate movement. Here's the Tonga region. Here's one on the North Island of New Zealand, 4.2, near Tokoroa. Is that how you say it? Look at all this. We've got 15 here. Let's see what else. I think 5s and 4s is what we're seeing. Turkey still got some activity. Japan 5.0, 5.8, Yamada. There's Alaska. Oh, look at this in the Bering Strait. Look at this. We've got 3 right here in the middle of the Bering Strait. 3.2. That was on the 26th. 2.8 on the 27th. And 3.1 on the 27th today. So we'll see more and more of these Arctic earthquakes as the weight on the land masses shift, especially with Greenland when it melts a lot. So there's Alaska. How many did they have? 613. Okay, and here in the U.S., here's 4.5 on the Juan de Fuca plate. So we also had at the geysers this week, it was active. 303 at the geysers, and I think I remember seeing a 4 here. Thought I saw a 4. I don't remember what day. But that's bigger than we normally see. Yeah, here it is. That was on the 25th. So normally we see them like 2s and under. So 4 is getting up there. And look at all this. Lots of activity from San Francisco down. See, I mean, it looks like it's kind of picking up to me. And there's Ojai. How many did we have at Ojai this week? 133. Yeah, Yeah, it was swarming last week with the hurricane down there too. And Reno, look at all of ours. So you can see the lines where they go. There's Yellowstone and so on. Oh, also, look here. 4.0 near Weston, Colorado. That's right on the Colorado-New Mexico state line. It also, look at this, another one just outside Amarillo, Texas, 2.3. That was on the 24th. West Texas. Look at this. There's a bunch. 44 in Texas. There. How many in West Texas? 34. So this is for a lot of oil drilling. It's just filled with oil drilling out there. Okay. So I think that's it. So that's my report for tonight. And we'll continue reading out of the book of Tobit, which is part of the Apocrypha, which are books that did not make it into the Bible. But were considered. Tobit chapter 4. In that day Tobit remembered the money which he had committed to Gabael in Rages of Media, and said with himself, I have wished for death, wherefore do I not call for my son Tobias, that I may signify to him of the money before I die. And when he had called him, he said, My son, when I am dead, bury me, and despise not thy mother, but honor her all the days of thy life, and do that which shall please her, and grieve her not. Remember, my son, that she saw many dangers for thee, when thou wast in her womb, and when she is dead, bury her by me in one grave. My son, be mindful of the Lord our God all thy days, and let not thy will be set to sin, or to transgress his commandments. Do uprightly all thy life long, and follow not the ways of unrighteousness. For if thou deal truly, thy doings shall prosperously succeed to thee, and to all them that live justly. Give alms of thy substance, and when thou givest alms, let not thine eyes be envious. Neither turn thy face from any poor, and the face of God shall not be turned away from thee. If thou hast abundance, give alms accordingly. If thou have but a little, be not afraid to give according to that little. For thou layest up a good treasure for thyself against the day of necessity. Because that alms do deliver from death, and suffereth not to come into darkness. For alms is a good gift unto all that give it in the sight of the Most High. Beware of all whoredom, my son, and chiefly take a wife of the seed of thy fathers, and take not a strange woman to wife, which is not of thy father's tribe. For we are the children of the prophets, Noah, Abraham, Isaac, and Jacob. Remember, my son, that our fathers from the beginning, even that they all married wives of their own kindred, and were blessed in their children, and their seed shall inherit the land. Now therefore, my son, love thy brethren, and despise not in thy heart thy brethren, the sons and daughters of thy people, and not taking a wife of them. For in pride is destruction and much trouble, and in lewdness is decay and great want. For lewdness is the mother of famine. Let not the wages of any man which hath wrought for thee tarry with thee, but give him it out of hand. For if thou serve God, he will also repay thee. Be circumspect, my son, in all things thou doest, and be wise in all thy conversation. Do that to no man which thou hatest. Drink not wine to make thee drunken, neither let drunkenness go with thee in thy journey. Give of thy bread to the hungry, and of thy garments to them that are naked, and according to thine abundance give alms. And let not thine eye be envious when thou givest alms. Pour out thy bread on the burial of the just, but give nothing to the wicked. Ask counsel of all that are wise, and despise not any counsel that is profitable. Bless the Lord thy God always, and desire of him that thy ways may be directed, and that all thy paths and counsels may prosper. For every nation hath not counsel, but the Lord himself giveth all good things, and he humbleth whom he will, as he will. Now therefore, my son, remember my commandments, neither let them be put out of thy mind. And now I signify this to thee, that I committed 10 talents to Gabael, the son of Gabrias, at Rages in Media. And fear not, my son, that we are made poor, for thou hast much wealth. If thou fear God, and depart from all sin, and do that which is pleasing in his sight. Tobit chapter 4. Well, I think those are good words for any time, just words to live by. And he was obviously a man of God, and the more we draw closer to God and Jesus, the more they'll protect us and provide for us and guide us and just keep us out of harm's way. And dark days are here, and they're going to be getting darker. And so if you haven't given your life to Jesus Christ, I recommend it now before it's too late. So I love you all, and I'm praying for you. And Lord willing, I'll be back next Sunday for another weekly update. I hope everyone has as good a week as possible. God bless you. Go in peace, and I will talk to you soon. Good night.